All right, let's take a look at our partial circuit again. We're going to figure out how to use the enable pin to control speed of the motor and on-off. Yeah. So again, we got our power connections. We got our plus 5 volts powering the internal chip logic. We got our ground to one of our 4 grounds. We got our plus 9 volts to our VCC2, our motor power supply. Y's are connected to the motor, and each Y is connected by an A pin, A for Arduino. And now we got a new connection. We got our enable pin of our L293D chip connected to pin 9. And the reason we jumped to pin 9 is because it's got this little squiggle next to it. It is a pulse width modulation capable pin, which we're going to use here. So since we can't vary the voltage, the Arduino is not capable of full digital to analog conversion. It can't put out 2.5 volts. It can't put out 3 volts. Well, aside from the power supply, 3.3. We're going to fake it using the pulse width modulation. Now, this is a bit like controlling a car where we don't have a nice, smooth analog speed control. Like we have a gas pedal that's essentially like a push button switch. It's on, full speed ahead, pedal to the metal, or it's off. So the way you'd control that potentially is you'd press it, let it go, press it, let it go, press it, let it go. And if you did that fast enough, you might be able to make it work pretty smoothly, which is what goes on here. Our pulse width modulation for Arduino varies a bit depending on the pin, but it's either about 500 times a second it's turning on and off, or 1,000. And in this case, it stays on longer if you're analog writing a higher number. If you've got a bigger duty cycle, and it stays on for less % of the time if you've got a lower duty cycle, if you're analog writing a lesser number. Okay, so that's pretty much it. Let's take a look at the code, because there's some funny stuff going on there. Nothing too crazy, but a little bit. So enable pin, not too hard to see. Notice in our circuit diagram, the enable pin was connected to pin 9. We also have a switch in the zoetrope circuit, and so this is the pin the switch is connected to in the zoetrope circuit, and we're holding the on-off button state in this pass-through loop and the last pass-through loop, because we're going to want to figure out if it's changed. So we need to check both the last pass-through loop, the state it was in, and this pass-through loop, the state it was in. And if they're different, you've either just pressed it or just let it go. So we have 2 things related to this enable pin. We have motor enabled, which is essentially an on-off state. Notice it's starting at 0, so it's off initially. And we have motor speed. Motor speed is controlled by the potentiometer, and that's how fast you want it to go. That determines what we're analog writing to the 9 pin, to the enable. And this controls whether we're writing anything at all. If we care about the potentiometer, should it just be off, or should we try and get the speed of the potentiometer? So then we got some pins setting up as per usual. Notice we are starting with the enable pin low, so it is starting off. It is beginning the program in the off state, so it won't start moving on you right away. And then we check to see if the button's currently being pressed or not. This is kind of an interesting little line here. So we're making our motor speed, and remember that controls how fast we're doing it, what we're going to be analog writing to the enable pin. And we're doing it to the enable pin, not the A's, because then we only need one pulse width modulation capable pin, and that controls the entire side, the entire motor. Otherwise, we'd have to do it for... Actually, it would probably be doable with one of the A pins as well. That would have been an option. But it would have been a lot more awkward. Much more annoying in the programming side. All right, so anyway, what this is doing, we are making our motor speed equal to whatever the potentiometer is giving us. We're analog reading it, so in our 0 to 5 volt range, we're getting back a number between 0 and 1023. We want to analog write that, though. So this little business right here is giving us a number between 0 and 1023. But we got to convert that into a number between 0 and 255 for use with analog write. So that's why we got this divided by 4, because that converts our range from 0 to 1023 to a range between 0 and 255. So we're set. We know what speed we should set it to if it is if it's supposed to be on at all. So here's the thing that determines whether it should be on or off at all. So if the on-off switch state, this pass-through loop is different, is not equal to the state it was in the last pass-through loop, that means we either just pressed it, it went from low to high, or we just released it, it went from high to low. So it has just changed. And we are doing if it's high. So at that point, we are just checking for, like if it's high now and it's just changed, that means you just press the button. So it is looking for the moment you press the button. And if that's the case, we've got this lovely bit of code again. Motor enabled is a true false 0 1 state thing, like is it on or off? And if you press the button and it was on, you want it to turn off, and if it was off, you want it to turn on. So we're just making the state equal to the opposite of whatever state it was in before. So make the state equal to not the state, the opposite of the state. So great piece of code. Love it. This is more motor direction stuff. And then we get to this guy. Now, if it's supposed to be on at all, if motor enabled equals 1, if motor enabled, yeah, is not 0, you could just do if motor enabled. That would work great too. We want to analog write to the enable pin our motor speed. Remember, our motor speed was that thing we read off the potentiometer and then divided by 4. So if the motor is supposed to be on, we use our pulse width modulation to the enable pin to set it to the right speed that we got off the potentiometer. Otherwise, we want to analog write 0 to the enable pin, which is basically just leave it off. It's exactly just leave it off. So if it's not supposed to be on, turn it off. And then this business here, we're done with this loop. So we're just saving the state that our button was in this pass-through loop so we can compare it. So next pass-through loop, we can compare the state there to the state before to see if the button was just pressed or just released. See, has the state changed? So to do that, we got to save the state, this pass-through loop, as the previous. Okay. That's it. Hope it makes some sense.